we took a look at our DNS. Now let's take this and put it into practice on our chart here. We have an example of our network here. Now our network is connected to the internet, which we have identified up here. I'll just put a big I next to it. So everything inside here is our local network, and then everything outside that is our, actually, there we go. Then everything outside that is our external network. So in our model here, we have our internal network, and then we also have our external network outside that. So our external network is going to be the internet. So we have our client computer here, and our client computer connects to our router, which connects to our sales server, as well as our internal DNS server. Our internal DNS server is also going to be our domain controller. Now, our internal DNS server is going to provide resolution for our internal names. Now, why do we need an internal DNS server? Why don't we just use our default DNS servers that, say our internet service provider gives us, or use an external DNS server such as 8.8.8.8? Well, these external DNS servers don't have records for our internal servers, and they're not going to let us write records for our internal servers on them. So we need to have an internal DNS server which is able to help us find our internal devices. So we have our client computer here, and it's looking to save a file, or it's looking to pull a file off of the sales server. So our sales server, sales.cybrary.local, we don't know its full path. Maybe we're just entering in a share path. So we type in that we want to access //sales/docs. And that's our shared folder for our sales documents. So our computer is going to say, okay, get rid of the /docs for a sec. I need to identify //sales. Now, this is not a fully qualified domain name. This is just our shorthands for our server name. So how does our computer know? How does it know where to begin searching for its local, or our local server? Well, the first thing our computer is going to do is it's going to tack on whatever local domain we're on. So we are on the same domain as this sales.cybrary.local server. So we're going to tack on, okay, sales.cybrary.local, and that's what our computer is going to do automatically for us. Now, the first place it's going to check for resolution is not going to be our DNS server. It's going to check our local hosts file as well as our cache. Now, our computer, in order to speed up and in order to save time, doesn't immediately go out and search for DNS on our server. It checks its local cache, and as we resolve different names, it saves those saved searches in our local cache so that we can find them quicker in the future. It takes time for a request to go out to a DNS server, bring back its IP address, and begin to route. So in order to speed that up, we have a cache that we save. In addition to our cache, we also have a hosts file. Now, what does our hosts file do? Well, our host file is going to provide us with a manual way to set on our local computer DNS entries. Back in the dawn of the internet, this is where we kept all of our DNS entries for everything, was a giant host file. But that very, very quickly became too large, too unmanageable to have for all of the computers and all of the servers on the internet. So we developed DNS. Well, our host file is still a location where we may edit or we may want to modify in order to change where our computer looks for certain servers, certain locations. Say if we wanted to, if we needed to have our sales.cybrary.local server, if we were doing some tests and we wanted that to look at a different server that we were planning on implementing, we could edit that hosts file. And then instead of having our computer go out and checking our DNS, our computer would check our hosts file first. So our computer is going to check for sales.cybrary.local in our cache and our hosts file. Now, it doesn't find it in either of those places. It doesn't find a DNS entry in either of those two places because we've never connected to this server before, so it's not going to be in our cache. Or maybe we just recently performed an ipconfig flush DNS, which flushes this cache and clears it all out. So it's not going to find anything there. So our computer is now going to send our DNS query to our DNS server that we have set up in our IP configuration, and we're going to set our default DNS server to be our internal DNS server here. So our computer is going to send its first query over to our internal DNS. Now, our internal DNS is going to look for sales.cybrary.local, and it'll find it in its entry. And it's going to say, oh, okay, sales.cybrary.local is 192.168.1.17. So it found it. So our DNS server is going to return our query and let us know, okay, hey, I found sales.cybrary.local and it's at this address. So then our computer just simply goes to that address after that, and it saves that search in its cache. DNS not only performs forward lookups, which is a fully qualified domain name translated directly to an IP address, but it can also do reverse lookups. Reverse lookups are where we search for the IP address to the fully qualified domain name. So if we didn't know who sales.cybrary.local was and we wanted to search for it, and we searched for 192.168.1.17, it would perform that reverse lookup and then let us know. So we have our forward lookups, and we found our sales.cybrary.local. Now, how do we find something that's going to be outside of our domain? How do we find something that's going to be outside of our domain? How do we find a server such as a Google server over here? Now, we don't want to have every single website in the entire internet saved on our DNS servers as the location that it goes to. Our internal DNS servers, rather. That would be way too unmanageable. That would be way too risky that someone's going to attempt to affect this DNS server. And it would just be, the configuration and the management of that would be just too incredible. So what we have set up we have the ability to forward DNS requests. Now, what that means is we have our client here searches for google.com. Maybe we just recently flushed our cache, so the location is not in our cache. It's not in our host file because we've never manually configured it. So we send the request out to our router. Our router sends the request over to our local DNS server. And our local DNS server says, I've never seen this one before, and I don't have any record for this. So I'm going to send this off to who I have set up as my forwarder. So our DNS server, we know that our internal DNS server isn't going to find everything. So when we set it up, we manually configure a location it goes and looks for addresses if it can't find them in its local manual configurations. So we set 8.8.8.8 as our DNS forwarder for our internal DNS server. So our internal DNS server can't find google.com, so it's going to search. It's going to send this query on back to our router and then out to the internet. When it gets there, this internet DNS server is going to say, oh, yeah, I know where google.com is. So it's going to send that reply back to our internal DNS server, who will then pass that along to our computer, who can now go out to Google and find where it's at, which is right here. So then it goes out to Google. So that's how our DNS works. That's how our clients and our servers, that's our sales server, our clients and our DNS servers work together. So we know now that DNS resolves fully qualified domain names to IP addresses and can also do reverse lookups where it resolves IP addresses to fully qualified domain names. So let's go ahead and now let's move on, and we're going to take a little bit of a closer look at DNS servers and DNS clients.